this video, we're going to talk about 2.4 Objective 2, where we find infinite limits numerically or graphically. Let's go ahead and get started. Y equals, and we're going to put in parentheses here x minus 2 for the numerator, and then divided by, and in the denominator, we're going to have x minus 1 squared, like that. And table settings, we're going to set our table to ask, and let's put in 1.1. We get negative 90. Let's put in 1.01. We get negative 9,900. 1.001. We get negative 999,000. And 1.0001, and we're going to get negative 9,999,000. All right, now let's put in 0.9. We get negative 110, 0.99, going to get negative 10100, then 0.999, we get negative 100,1,000, and then 0.9999 is negative 100,000,1,00,00. All right, and we're going towards negative infinity here. Three zeros and then 4 zeros. Always one more zero at the end over here than there was in between the ones there. That's what I was looking for. All right. So 1, 3 zeros, 1, 4 zeros, 1, 2 zeros, 1, 3 zeros, 1, 1 0, 1, 2 zeros, 1, 0 zeros, 1, 1 0. All right. So that's what those numbers are there. Let's go ahead and look here now at the graph and determine what's going on with the limit here as we approach 4. From the left, we're going to positive infinity, and from the right, we're also going to positive infinity. So we can say here that the limit is going to positive infinity. Your teacher may want you to say that the limit does not exist because it increases without bound, but our options here are to give a answer that's either a number or positive or negative infinity, and we only use the second option when it does not exist and is neither infinity nor negative infinity. As we approach 3 here, it's coming at negative infinity from both sides, so the limit is going to be negative infinity. Now let's look graphically here. As we approach 2 from the left, we're going to positive infinity. As we approach 2 from the right, we're going to negative infinity. So I can't say that the limit exists because it's going to neither negative infinity nor positive infinity from both sides. 4 from the left is going to negative infinity. 4 from the right is also going to negative infinity. So we're going to say that the limit there is negative infinity because it's doing the same thing from the left and the right. As I approach -1 from the left, I'm going to negative infinity. As I approach -1 from the right, I'm also going to negative infinity. So that limit is negative infinity. As I approach 5 from the left, I'm going to positive infinity. 5 from the right, I'm going to negative infinity. So that limit doesn't exist because it's not approaching either positive nor negative infinity from the left and the right. Times x minus 1. We're going to have asymptotes at 0 and positive 1. And we're going to have positive, negative, positive. I think it's going to be that first one, but let's look in our picture here of 1 divided by x squared minus x. And let's set our window at -1 to 2. And then let's say by ones. Those were by increments of a quarter if we're going out to -1. And then -10 to 10. And those are by twos. And that certainly does look like number for the first one, A. So now that we have the graph, determine what happens as we approach 0 from the left. Go into positive infinity. As we approach 0 from the right, we're going to negative infinity. So as I approach 1 from the left, it's going to be over here. 1 from the left, it's going to negative infinity. 1 from the right, it's going to positive infinity. Now let's graph the function y equals tan x. We're going to have a window of negative 2 pi to 2 pi increments of pi over 2. And then -10 to 10 by ones. Okay. And Let's make sure that we are in radian mode. Good. All right. Looks like that. So that's D. We get so at 7 pi over 2. So we approach that from the right. That is 3.5 pi. It's outside of our window that's here, but we can see that that's going to do the same thing as any other odd multiple of pi over 2 from the right. So here's pi over 2 from the right is going to negative infinity. So 1, 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, any odd multiple of pi over 2 from the right is going to go to negative infinity. Odd multiple of pi over 2 from the left is going to go to positive infinity. And then same thing, that's an odd multiple of pi over 2 coming from the right, so that's negative infinity. And odd multiple of pi over 2 coming from the left is going to go to positive infinity here. And let's see here. Now we've got this graph. Given the graph of f of x equals x to the 1/3 in the following figure, answer parts A and B. Find the slope of the secant line that passes through 0, 0 and h f of h. For in terms of h for h greater than 0 and for h less than 0. So that's going to be y2 is going to be h cubed h to the 1/3 0 over h minus 0. This is h to the 1/3 over h to the negative 2/3. This is when h is greater than 0. So that is the same thing as 1 over the cube root of h squared. Let's check from the left-hand side now and say that this point over here is going to be negative h actually that's the same thing. So this is h to the 1/3 here as well. If h is less than 0, we're going to get the same thing. So that's regardless. So that's C. And calculate the limit of the slope of the secant line found in part A as h approaches 0 from the left and the right. And it won't matter if it comes from the left or the right because this is being squared here. So in both cases, this is going to be a positive number down here that's going to get closer and closer to 0. So this is going to get closer and closer to positive infinity both times. That's A. And that is it for this video. We'll come back next time and we will talk about 2.4 objective 3. See you for the next video.